I thank all of you for watching my videos all these years. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solution of a problem from the question paper CSIR National Eligibility Test held in the month of June 2023. This question is from the section Real Analysis and it is about the convergence of sequences. This question is from the part C, which is a multiple select question. There can be more than one answer and it carries 4.75 marks. The question ID is 704097. This question is suitable for all these examinations. Right. The given question is, let f be a function from the set of real numbers to itself defined as f of x is equal to 1/4 plus x minus x square. Given a belongs to R, given a is a real number, let us define the sequence xn by x naught is equal to a and xn is equal to f of xn minus 1 for n greater than or equal to 1. Which of the following statements are true? We are given four options. Option 1, if a is equal to 0, then the sequence xn converges to 1 by 2. Option 2, if a is equal to 0, then the sequence xn converges to minus 1 by 2. Option 3, the sequence xn converges for every a belongs to the open interval minus 1 by 2, comma 3 by 2 and it converges to 1 by 2. Option 4, if a is 0, then the sequence xn does not converge. Right. Let's now discuss the solution of the problem in detail. We have f, a function, from the set of real numbers into itself, defined by f of x is equal to 1/4 plus x minus x square. We are given a is a real number and the sequence xn is defined by x naught is equal to a and xn is equal to f of xn minus 1 for n greater than or equal to 1. The sequence is inductively defined. Right. Now, xn is equal to f of xn minus 1 for n greater than or equal to 1. Right. So, this means f of xn minus 1 means f of x is 1/4 plus x minus x square. F of xn minus 1 will be equal to 1 by 4 plus xn minus 1 minus xn minus 1 square. Agreed. We have taken a minus common and written as xn square minus xn minus 1 bracket close plus 1 by 4. Right. Let us make this xn square, that xn minus 1 square minus xn minus 1 as a perfect square. How do we write? Minus xn minus 1 minus 1 by 2 whole square and adjust the constant term. To do so, we add 1 by 4 plus already there is a 1 by 4. Agreed. And that is equal to minus xn minus 1 minus 1 by 2 whole square plus 1 by 2. 1 by 4 plus 1 by 4 is 1 by 2. Right. This implies xn is equal to minus xn minus 1 minus 1 by 2 whole square plus 1 by 2. So send this 1 by 2 the left hand side. We write xn minus 1 by 2 is equal to minus xn minus 1 minus 1 by 2 whole square for n greater than or equal to 1. Right. Now, let's now generate the terms of the sequence using this formula. Right. N is equal to 1. Then x1 minus 1 by 2 is equal to minus x1 minus 1, 0, x0 minus half square. But x0 is given to be a is equal to minus a minus 1 by 2 whole square. N is equal to 2. x2 minus 1 by 2 is equal to minus x2 minus 1, x1 minus half square. But in the above, x1 minus 1 by 2 is equal to minus a minus 1 by 2 whole square. Now, for that it is square again. So, it will be equal to minus a minus 1 by 2 to the power of 2 into 2. 2 square and again square. So, that is the n is equal to 3. Then x3 minus 1 by 2 is equal to minus x2 minus 1 by 2 whole square. In the above, we have seen x2 minus half is equal to minus a minus 1 by 2 power 2 into 2. Now it's again a square. Then it will be minus a minus 1 by 2 to the power of 2 into 2 into 2. Now look at the pattern now. So the first one is minus a minus 1 by 2 to the power of 2 power 1. The second minus a minus 1 by 2 to the power of 2 square. In the next one, in this it is equal to minus a minus 1 by 2 to the power of 2 cube. So go on generating. We get xn minus 1 by 2 is equal to minus a minus 1 by 2 to the power of 2 power n. 2 power n. Send this minus half from left hand side to the right hand side. So this will imply xn is equal to 1 by 2 minus a minus 1 by 2 to the power of 2 power n. Take the limits on both sides. Limit n tends to infinity of xn is equal to 1 by 2. There is no n in this, therefore it is independent of n, therefore limit will not come here. Minus limit n tends to infinity of a minus 1 by 2 to the power of 2 power n. We continue in the next slide. Right. We have this one. Right. Right. Now, if a is equal to 0, put a is equal to 0, then it will be limit n tends to infinity of xn is equal to 1 by 2. Limit n tends to infinity of 1 by 2, because a is 0, to the power of 2 power n. As n tends to infinity, this will tend to 0, because 1 by 2 is less than 1. Is less than 1. So, when this becomes 0, it is 1 by 2. So now, that means, this means if a is 0, then the sequence xn converges to 1 by 2. That's the conclusion we brought. Let's look at our options. Our option 1 says if a is equal to 0, then the sequence xn converges to 1 by 2. Thus, option 1 is true. Now, option 2, if a is equal to 0, then the sequence xn converges to minus 1 by 2. No, it is converging to half only. Therefore, option 2 is not true. Option 4, if a is 0, then the sequence xn does not converge. No, it is converging to 1 by 2. Therefore, option 4 is not true. Thus, option 1 is true, and option 2 is not true, and option 4 is not true. Right. We are left with option 3. Right. Now, now look at the limit n tends to infinity of xn is equal to 1 by 2 minus limit n tends to infinity of a minus 1 by 2 to the power of 2 power n. Now, if I take modulus of a minus 1 by 2 less than 1, if I take modulus of a minus 1 by 2 less than 1, then limit n tends to infinity of a minus 1 by 2 to the power of 2 power n will be 0, because it is less mod, the mod of a minus 1 by 2 is less than 1. Right. So, if mod of a minus 1 by 2 less than 1, then limit n tends to infinity of xn is equal to 1 by 2 minus limit n tends to infinity of a minus 1 by 2 to the power of 2 power n. And when mod a minus 1 by 2 is less than 1, then this limit will be 0. So, you will get 1 by 2. You will get 1 by 2. Now, what is mod of a minus 1 by 2 less than 1? So, it is equivalent to minus 1 less than a minus 1 by 2 less than 1. It is equivalent to add 1 by 2 throughout. So, you will get minus 1 by 2 less than a less than 1 plus 1 by 2, that is 3 by 2. That means this is equivalent to a belongs to the open interval minus 1 by 2 to 3 by 2. So, thus the sequence xn converges to 1 by 2 for every a belonging to the open interval minus 1 by 2, 3 by 2. So, that is precisely the option 3. So, thus option 3 is true. So, the answer to this question is options 1 and 3. I am sure that you have understood the solution of this problem. Right. So, that's the detailed discussion of the solution of a problem from real analysis, and which is related to the convergence of sequences. Agreed. So, I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Let's hope to meet you once again in another episode of learning. I wish you all the best. Thank you.